Hello, my dear students. How are you? I hope that you will be very well, and I am also very well. Today, I am going to discuss units and measurements. In last class, I have already discussed about. In last class, I have already discussed about what is dimension, and I have given some examples such as dimension of force, dimension of fundamental quantity. Total number of fundamental quantities are equal to 7, and I have already find dimension of all fundamental quantities. Today I am going to discuss some another physical quantities, and I will find dimension of each quantity. Here I am going to find dimension of distance. Distance just like length, therefore dimension of distance will be equal to L. I have already taught you about fundamental quantity. Total number of fundamental quantities are equal to 7, and I have already determined dimensions of all fundamental quantities in previous class. Today I am going to discuss dimensions of some other physical quantity such as distance, displacement. Displacement is also just like length, therefore its dimension will be L. You can write it also in the form of this, okay, because we know that if power of any quantity is 0, then its value will be equal to 1. Okay, a speed can be defined, a speed is defined in the form of this distance by time. Therefore its dimension will be distance just like length, therefore its dimension is L, and dimension of t is capital T. Because I have already discussed in previous classes about the dimensions of fundamental quantity. Okay, it can be written as this because its value is equal to 1. Now I am going to find dimension of velocity. What is velocity? Displacement by time is called velocity. Displacement is length L, time is t, Lt minus 1. Here we see that dimension of a speed and velocity are equal. Dimensions of a speed and velocity are equal. Therefore, some questions can be asked in IIT and NEET in the form of which of the following pairs have same dimension? Which of the following pairs have same dimension? What is the dimension of acceleration? You can find dimension of any physical quantity with the help of formula of their units. You can find dimensions of any physical quantity, dimension of any physical quantity with the help of formula or unit. Unit of acceleration is meter per second square. Therefore, L upon T square, it can be written as like this and like this. Okay. Now I am going to find dimension of force. I have already determined dimension of force in previous class. Force is defined as the product of mass and acceleration. Therefore, its dimension will be, this is mass m, this is acceleration. Dimension of acceleration will be Lt minus 2. Therefore, dimension of force is equal to ml t minus 2. Now I am going to find the dimension of work. What is the formula of work? It is defined as the dot product of force and the displacement of point of application of the force. Okay? I have already discussed in chapter vector chapter. F dot S means Fs cos theta, because I know that A dot B is equal to AB cos theta, where theta is the angle between A vector and B vector. Here force has dimension this and displacement has dimension L. Cos theta has no dimension, means dimensionless, because cos theta is equal to base by hypotenuse. Base is also length and hypotenuse is also length. Length cancel out and result will be equal to 1. If dimension of any physical quantity is equal to 1, then I can say that it is dimensionless quantity. Okay? Dimension of any energy, like potential energy, kinetic energy, heat energy, whose dimension is equal to work. Dimension of work will be equal to the dimension of any type of energy, such as potential energy, kinetic energy, heat energy, electric potential energy, etc. Dimension of cos theta or any trigonometrical ratio will be equal to 1. This can be written as like this. Any number which has no unit, dimension of any number having no unit will be equal to 1. Dimension of 3, dimension of 4, dimension of 7, 8, 9, etc. will be equal to 1. That is dimensionless quantity. What is charge? Charge will be equal to current into time. Current is fundamental quantity, therefore its dimension will be either I or A. It can be written as I or A. Time, dimension of time is T, therefore IT or AT. Okay? We know that the gravitational force acting between any two point masses can be written as this: F is equal to G1 M2 by R square. Here G is capital G, not a small g, and it represents universal gravitational constant. Universal means its value does not change in any medium. Its value will remain same in all type of medium. If you go to other planets such as Mars, Jupiter, etc., universal gravitational constant, the value of universal gravitational constant does not change. Okay, therefore it is said to universal, said to, it is said to be universal, it is said to be universal. Okay, dimension of kinetic energy, I have already said that all type of energy have same dimension like work. As for example, kinetic energy, potential energy, gravitational potential energy, energy of a spring, all have same dimension like work. mgh, m is mass, g is acceleration. Value of g is 9.8 meter per second square. G is acceleration. Dimension of acceleration LT minus 2, and h is height, just like length. Okay. Here I see this expression, which is equal to the dimension of work. Therefore, I can say that any type of energy has same dimension like work. Now I am going to discuss this. This is momentum. Momentum is equal to mass into velocity. I have already determined dimension of mass and velocity. Mass, dimension of mass is m, and dimension of velocity is lt minus 1. Therefore, dimension of momentum will be equal to mlt minus 1. Impulse, it is also called as linear impulse. Momentum means, simply momentum means linear momentum. This is force into time. Force, time is dt. dt means a small time, very small time. It is also called as change in time. Change in time means final time minus initial time. Time minus time will be equal to time. As for example, 5 seconds minus 2 seconds is equal to 3 seconds. Okay? Time minus time is equal to time. Therefore, dt is time. Force has dimension force has dimension ml t minus 2, and time has dimension capital T. Therefore, dimension of impulse will be equal to ml t minus 1. You have already studied in previous classes in 10th or 9th. Okay? You have already studied about this force acting between any 2-point charges, which is equal to F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Here this symbol is called epsilon. This symbol is called as epsilon naught. Absolute permittivity of free space or air or vacuum, just like refractive index. Okay? Epsilon absolute permittivity of a medium, you can study in electrostatics about these terms. You can study in electrostatics about these terms. These terms, epsilon r, it can be also denoted by K. It is called a relative permittivity of a medium. Okay? It also called as dielectric constant. Also called as dielectric constant. Dielectric constant. It is also called as dielectric constant. Okay? For air, free space or vacuum. In vacuum, this will be double C, not W, not double C. Epsilon R is equal to 1. Just like refractive index. Refractive index for air or vacuum is equal to 1. Here, same as epsilon R is equal to 1. Okay? F is equal to 1 upon 4 pi epsilon of Q1 Q2 by R square. We have to find the dimension of epsilon naught. Therefore, epsilon naught is taken on left side and F is taken on right side. Dimension of epsilon naught will be equal to this. Here Q1 Q2 are charges. Dimension of charge is IT. Therefore, IT to the power 2. Okay? 4 pi is a number. Therefore, dimension of 4 pi is 1. F is force has dimension this, and R is the separation between the charges. This means it is just like length square. Therefore, it can be written as like this and it can be written like this. Okay? This is dimension of epsilon naught. This question has already asked in IIT JEE. It can be written as epsilon by epsilon naught. Both are similar. Therefore, both have same units, and therefore epsilon r is unitless and dimensionless quantity. Any physical quantity has dimension 1, then it is said to be dimensionless quantity. I have already discussed about this. Okay? If dimension is 1, therefore it will be dimensionless quantity. In magnetism, M1, M2 are pole strength. Pole strength means a strength of pole due to which it attracts minute particles of iron. Okay? Means pole strength means a strength. A strength means power. It is a scalar quantity. F is equal to mu naught by 4 pi epsilon naught M1 M2 by R square. Just like epsilon r, epsilon naught, epsilon. Here it is mu naught, mu r. Mu naught is absolute permeability of air or vacuum or free space. Just like refractive index, mu is absolute permeability of a medium. Mu r is the relative permittivity of a medium. Okay? Mu r is defined as mu by mu naught. It is unitless and dimensionless because both quantities have same units. F is equal to mu naught by 4 pi m1 m2 by r square, where r is the separation between the poles. Mu naught can be written as like this. Here F is force, therefore dimension of force is mlt minus 2 and r square L square and m1 m2 are pole strength. Pole strength has unit ampere meter. Dimension of ampere I or A. Dimension of meter L. Therefore IL. Okay. Okay. This can be written as like this. This is dimension of mu naught. Pole strength. Dimension of pole strength is, this is unit ampere meter. You can find dimension of any physical quantity by using formula or unit. This is unit of pole strength, therefore A is ampere I, unit of current. M is meter is length. Okay, just like length. F is equal to Q, where E is electric field intensity or electric field. Okay, actually electric field is defined as the affected region around a charge up to infinite. But I cannot measure this area up to infinite here. Therefore, electric field means electric field intensity. Electric field at any point in an electric field is defined as the force experienced by unit positive charge placed at that point. Okay? Electric field intensity will be equal to force upon Q. Force is this and Q is IT. Therefore, dimension will be like this. Okay? Magnetic field, it is also called as magnetic induction, magnetic field intensity. All are same. F is equal to MB, where B is magnetic field and M is pole strength. This is force and this is pole strength, ampere meter, IN. Therefore, its dimension will be MT minus 2, I minus 1. Now I am going to discuss like this. This is heat energy. I have already said that dimension of any energy will be equal to work. Therefore, here dimension of heat energy is ml 2t minus 2. This will be equal to dimension of work. A specific heat capacity defined as like this. H is equal to ms delta T, where H is heat energy, M is mass, S is specific heat, and delta T change in temperature. Temperature minus temperature will be temperature. Okay. Therefore, dimension of a specific heat capacity, H by M delta T. H is heat energy, M is mass, M, and delta T is Kelvin. Dimension of temperature is Kelvin. This can be written as like this. Okay. Latent heat. Actually, a specific heat capacity you can study in future. A specific heat is defined as the amount of heat energy required to increase the temperature of unit mass of a substance by 1 degree C or 1 Kelvin. Here latent heat. Simply latent heat means the amount of heat energy absorbed or released to change the state of mass, a state of a substance. Okay? Here it is not specified, but in a specific latent heat it is specified for unit mass. It is defined as the amount of heat energy absorbed or released to change the state of unit mass of a substance. But in this, there is no mention about the amount of mass. You cannot calculate mathematically latent heat, but you can calculate a specific latent heat mathematically. Therefore, latent heat means a specific latent heat. A specific latent heat will be H by M. H is heat energy and M is mass. Like this, a speed square, velocity square. Because a speed and velocity have same dimension, which is equal to LT minus 1. Today I am going to end the class. Have a nice day. See you again tomorrow. Namaskar from my side.